Okay, good morning everybody. So I'm doing the review today. It's Wednesday, but I'm going to give this to you tomorrow. One of the things that I've done that you'll be happy about is because we're on shortened periods, the first 10 of this review will not be on the quiz, which I guess is okay because we did all this in geometry. At least I hope you did it in geometry. So, dang it, all that great stuff we don't have to do. So let's look at 11. Okay, so I'll start with number 11. So it's our review, and we're going to need to do this in class on Thursdays, but I wanted to put the video up there. Okay, number 11. First of all, 1/2 power, same thing as a square root. So it's really the square root of 16, and we know that is 4. Boom. Pretty easy. Number 12, same type of thing. With a negative exponent is 1 over. Negative exponent, highlight that. Negative exponent, 1 over. 1 over, and then we're going to get the 5th root of 32 to the 4th power. Okay, now 5th root of 32, so what times what times what times what times what makes 32? Well, that's got to be a 2. 2 times 2 times 2 times 2 times 2 is 32, so that I get 1 over a 2 to the 4th power. 2 times 2 times 2 times 2 is 16. 1/16. There's my answer. Okay. 13. We did something like this on the warm-up yesterday. So first of all, I'm going to bring the exponent in to both. So I'm going to bring the exponent into both first, and I will have a 5 to the negative 2 because I multiply exponents, and over a 10 to the negative 1 because I multiply exponents. Okay, and then what I'm going to do is flip because of negative exponents. So I'm going to bring this one down. 5 squared over, bring this one 10. So that's the same thing as 10 over 25, which would reduce to, let's see, divide both by 5. I could have 2/5. I like that answer, 2/5. Okay, all right, this is a math class. We can do it. We can do these fractions. We can. Number 14. So these are both cube roots. So let's just go 2 goes into 32. 16 times, right? I'm going to reduce that. So let me rewrite this as the cube root of 4 times the cube root of 16. Okay, now, what is 4 times 16? I don't know. 4 times 16 is probably 64. 4 times 16 is probably 64. Yes. So I get the cube root of 64. And then, wait a minute. I know that's one of my perfect cube roots. That is, because 4 times 4 times 4 is 64. So I can go straight to calling that plain old 4. Okay? All right, turn the page. All right, number 15. All right, let's see, what do I have? Get a piece of graph paper out so we can see this. Oh, doggone it. I need a good piece of graph paper, but we'll just put this on here. Okay? Good enough. So, boy, you'd think I'd be better prepared than this, wouldn't you? Hope so. I can't even find a pair of scissors. And I'm wasting time, huh? That's right. It's just recording. All right, let's go ahead and graph 15. Now, you can put this into Desmos. I can do it just simply by using my calculator or my brain. I can use my brain to do this one. So I know that what a square root graph looks like. We've looked at the parent function. I'll put that down so you can see the parent function. Parent function looks something like this. My parent function looks like, put it in blue, 0, 1, 1, 2, 1, 2, 3, 4. Square root of 4 is 2. 4, 5, 6, 7, 8, 9. Square root of 9 is 3. So here's my parent function, right? This one, we're going to do a couple of things with it. We're going to move the endpoint to a opposite, to a positive 1, 3. So we're going to take the positive 1, 1, 2, 3. And then the second thing, because of this negative, is we're going to turn it and flip it upside down. And so instead of going up, it's just going to go down. And 1, 2, 3, 4... and 9, and there it is. Okay, now, domain and range. Okay, I can do domain and range on this one. So the domain has got to be all the x values. So here's my graph. It starts at 1 and goes over. Domain is x is greater than or equal to 1 And the range, let's see, starts at a height of 3 and goes down. Y is less than or equal to 3. There's my domain and range. Oh, maybe I'll cut this a little, slice it down so that I have room for my other graph, okay? Let's see, squeeze it over there. There we go. Put it right up there. So you can see it on my paper, okay? Let's look at number 16. Now, 16 is a cube root, and hopefully remember what a cube root looks like. If you don't, I'll show you the parent function of a cube root. Okay, so let me put that on my graph real quickly. All right, a cube root. Take that down. So first of all, my parent function, I'm doing cube roots. So if I need my parent function, go ahead and put down my XY axis. Parent function I'll put in blue. So I'm going to go, alright, the parent function looks like this. 1 cubed, 1, 2, 3, 4, 5, 6, 7, 8. Cube root of 8 is 2, and there's a whole bunch of other numbers in between the decimal numbers, but I don't want those. Negative 1, the cube root of negative 1 is negative 1. A cube root of 1, 2, 3, 4, 5, 6, 7, 8 is negative 2. So it looks like that. Okay, now, that's my parent function. Let's move it. So to move this particular one, we're going to move it to, we're going to move the inflection point. I'm going to move the inflection point to positive 2, opposite the inside, 1. And so we'll just regraph it. Okay. So it's going to look like this, and then 1, 2, 3, 4, 5, 6, 7, 8. We're going to go 1, 1, and 1, 2, 3, 4, 5, 6, 7, 8 is going to be off my graph. That's okay. So my graph is going to look something like that. Okay. Domain looks pretty wide. In fact, any x value is okay. It goes on forever in both directions. All real numbers. That's the symbol for all real numbers. Domain, and for range, same thing. It's always going up forever, just very slowly going up. So the range, same thing. Y is equal to all real numbers, also for the range. Okay. All right, let's take a look at 17. We want to solve for x. So I might need some extra paper to do some of these. So I'm just going to get some scratch paper out. And we'll do 17, 18 on a different piece of paper so we have room to do them. Okay, so 17, let's see. 2x to the 2/3 equals 8. All right, let's solve. First step, divide by 2, divide by 2. Get rid of that 2, so I'll have x to the 2/3 equals 4. And then I'm going to undo my exponent, my fractional exponent, by multiplying by not 2/3 but 3/2. Okay, so I'll take this to the 3/2 power. Let's see, that gives me 6, which is 1, or x, and then that's going to be the square root of 4 is 2 times to the 3rd power should be 8. If you're not sure how I got that, you can always use a calculator if you need it. Batteries are low, okay, well, whatever. I'm just going to go then 4 to the power of 3 divided by 2, and I get an answer of 8. Sure enough, I knew it was 8. I did. I knew it was 8. All right, let's look at 18. Okay, 18, I've got the cube root of 8x minus 1 equals negative 5. Okay, so I'm going to cube it, and then we're going to have a cube, and the cube root cancel. 8x minus 1 equals negative 5 times negative 5 times negative 5 is negative 125. Okay, plus 1 plus 1. 8x equal to negative 124. Negative 124. And, oops, sorry, divide by 8. Divide by 8, that should be 32. I can just see that. It goes in there 3 times. X equals a negative 32. Now, negatives are okay with cube roots. Okay, so I'm going to keep that answer. I need to check that answer. Now, I'm going kind of fast, and if at some point in time you say, hey, Mr. Davies, slow down, just stop the video, rewind it if you need to, or whatever, okay? Now, 19. 19 square root. 2x plus 1 equals 2 times the square root of x minus 6. Okay, here's 19. So, I've got square roots on both sides, so let's just square it. Square the square root, square the square root, because the square eliminates or cancels out the square root, okay? So then I get a 2x plus 1 equals, well, I got to square the 2. Don't forget to square the 2 because it's on the side. 4. Square cancels the square root, x minus 6, okay? So, okay, let's keep going. 2x plus 1 equals 4x minus 24 minus 2x, 1 equals a 2x minus 24 plus 24 plus 24, 25 equals 2x. Divide by 2, and I think I get what, 12.5 equals x. Okay, and that answer will be fine. You won't need to worry about that answer because it will not create any negatives inside the square roots. Okay, 19. There you go. All right, let's take a look at 20. And I'll slide 20 over on this side so you guys can see 20. Now 20 is an inequality, so there's two parts to 20 that we have to be careful about, okay? One, you can't take the square root of a negative. So right off the bat on number 20, the first thing I'll do is say, well, 3x plus 3 has to be positive. So I need to make sure that in here I do not get a negative. So I'm going to make sure that this value is not negative. To do that, I make sure that 3x plus 3 is greater than or equal to 0, okay? So just solve 3x minus 3 is greater than negative 3. Divide by 3, x has to be greater than or equal to negative 1. So if x is negative 1, you get 0, okay? If x is negative 2, no, bad news. You're going to take the negative square root. You can't do that. So my first part is this, okay? That's part of my answer. The other part is just to solve it, which we can do, okay? I'm just going to go through and I'm going to solve this. Square root of a 3x plus 3 has to be less than or equal to 6. And I'm just going to solve it, just like I solved all of these. So I'll square it to get rid of the square root. I'll have a 3x plus 3, because the square cancels the square root, is less than or equal to 6 squared, which is 36. Minus 3, I've got 3x is less than or equal to 33. Divide by 3, x is less than or equal to 11. Okay, so both of these answers are correct. I need both. What I might do, though, which I like, is I like to write it in set notation. Set notation is much better, so I'm going to say negative 1 is less than or equal to x, which same thing as if you read it backwards, greater than or equal to, which is less than or equal to 11, okay? That is the better answer. I like that one, okay? All right, let's see what I got left. 21, okay? 21, I can probably fit on here. Probably do it right on here. I've got enough room. Okay, so step 1, square both sides. I think we've done this problem before. It's good. So 4 squared, we have to square the 4. We have to square the 4, which is 16. The square cancels the square root, so I get x plus 1 equals x plus 1 times x plus 1, okay? And then I'm going to distribute, that times that. 16x plus 16 equals, well, I'm going to FOIL this, x squared plus a 1x plus another 1x makes it 2x plus a 1 times 1 is 1, okay? All right, now, I need to set it equal to 0, so I'm going to factor it, so I'm going to go minus 16x, minus 16x, minus 16, minus 16. So what am I going to get? I'm going to get 0 equals x squared minus 14x minus 15. It will factor, okay, it will factor x minus 15x plus 1 because negative 15 times 1 is negative 15, but negative 15 plus, if I do my FOIL, shouldn't make a negative 14, but my answers are my mini equations, so my answer is x equals 15 and x equals negative 1. Now the negative 1 scares me a little bit, but if I take a look at my original problem, I think the negative 1 is going to be okay. Put negative 1 right in for x. Negative 1 plus 1 is 0. Okay. And negative 1 plus 1 is 0. Okay, so I'm going to keep both answers, all right? So that's what I have, and we'll work on this a little bit in class as well. So have a great day. I will see you all tomorrow.